Hi guys, today we're going to take a look at lesson 79, estimating areas, and for this we need to go to our book. So I'm going to flip over and we'll take a look. Okay, so we're looking at a diagram of a kind of an irregular shape, and it says Tucker balanced 1 foot on the scale. He wondered how many pounds per square inch the scale was supporting, meaning how much of his weight was on 1 square inch of his foot. So he traced the outline of his shoe on a 1-inch square grid and counted squares to estimate the area of his shoe. So here's what he came up with. You'll notice on here, okay, that there are some little dots, okay? And what it says below is that to estimate the area of the shoe print, Tucker counted the complete or nearly complete squares within the shoe outline as whole squares. Then he counted the squares that were about half within the outline as half squares. Those are the ones with dots. He counted 30 full or nearly full squares and 4 half squares. Okay, so 4 half squares would be the same thing as 2 whole squares. Now you're going to notice that this stuff on the perimeter, where is my, there I am, the little tiny guys, don't get counted at all, okay? So if we turn it over, okay, it says Tucker estimated that the area of his shoe print was 32 square inches. He weighs 116 pounds, so he divided his weight by 32 inches squared, and he found that his weight was about 3.5 pounds per square inch of his shoe or his foot. And you can calculate this too at home. Okay, so the question says, would the number of pounds per square inch on each foot be greater or less than 3.52 if Tucker stood on 2 feet, okay? And so I'm kind of giving you the answer, but if you think about it, if all your weight is on 1 foot, then it would make sense that if you had 2 feet, then your weight would be distributed more evenly, so it'd be less weight per square inch, okay? All right, so we're gonna go down here to this diagram. It says to prevent a 500-pound piano from damaging the floor, the owner put 6-inch diameter circular casters, like wheels, under the 3 legs of the piano. Use Tucker's method to estimate the area of each and find the pounds per square inch the floor supports. Okay, so we take a look at this one, and you can kind of see in there, if you were to use your pencil and do the same technique, all the dotted ones are roughly half, and all of the full or the whole or nearly whole ones are counted as whole, okay? So I'm going to actually flip over here to my diagram. Sorry for the ride. So this is what it looks like. It's a piano. The piano weighs 500 pounds, and what he found by counting those circles is that each one had 28 square inches. So that 500 pounds is distributed over 3 casters that are 28 square inches. Okay, so 28 times 3 gives us 84 square inches total of caster space. So we take 500 pounds divided by 84 inches squared, and we get that for every square inch, there's 6 pounds of weight on that piano. Now, I think the question goes on to ask, is it the same on every single caster? Well, let's look at it. I mean, if you think about the inside of a piano, it's quite possible that this part with the keys and some of the other stuff is heavier, so these two might bear more weight than this one. So probably they're not distributed evenly. It might be that each of these is 10 pounds per square inch, and this back here is only 4, but it's hard to say. But the average comes out to 6 pounds per square inch, okay? So I'm just going to flip up here to a little diagram I drew. This is how you want to think about it, that for every whole square or nearly whole, that counts as a whole one. And then any that are half or nearly half, you can count halfway. So if there's 6 half ones, that would actually be 3 whole ones, okay? Because 6 halves is 3 whole, and you'd end up with 9. So here's your activity. I'm going to show you mine. You are going to trace your hand on the next page. Your fingers have to be closed. Okay, so it's going to look like this, not like this, like this. And you're going to trace your hand and kind of cut it off at the wrist. And then you're going to count how many grids. So I'm going to show you mine. Okay. So you can see I traced my hand. Here's my hand. Okay, I took my ring off. Traced my hand, and then I went through and I looked for any of them that were halfway or roughly halfway, and I marked them with green dots. Okay. And then like these little ones, I didn't even count. I suppose if you wanted to be super accurate, you could say like that quarter and that quarter would equal a half, right? And you could do 4 of those might equal a whole. I don't know if you want to get technical. But we're going to work on halves and wholes here. Okay, so I went around and I saw that counted it, didn't count it. It looked like less than half. Okay, and it's not an exact science, so don't fret over whether should I count it or not count it. Like these look even a little small, but I went ahead and counted them. Okay, so I did those, and then to keep track, I did all the ones that I'm going to count as whole, and I counted the dots as I went. Okay, so for mine, I ended up with 108 blue dots or whole squares, and there were 24 green ones or half squares. And so 24 divided by 2 gave me 12 whole squares. So what it's going to ask you to do is estimate the whole area of your hand. Okay, so here's what I found. Is I had a 108 whole squares and 24 half squares, which was 12. And I added them up, and my hand estimated at about 120 units squared. If those were square centimeters, which I suspect they are, that would be accurate. Okay, so you need to hit pause. I want you to do practice set. You're going to do A and B, and then I'm going to go over the answers with you. So go ahead and hit pause, and we'll go through it. Okay, so you're going to find that A, you should have come up with, if you were counting them, and hopefully you erased your little pencil marks if you dotted them in the book, that there were 9 whole squares and 6 half squares. Now, if you didn't get an exact match to mine, that's fine. But you should have gotten roughly 12 square kilometers, or if you had said 13, that would be fine, okay, on that. I think it was a pond or a lake or something, okay? Now, the next one's kind of interesting. I'm going to zoom in on the picture over here. It's not very clear. Sorry. That's a little better. Okay, you notice the blue square in the corner. That's what they're talking about. They're saying that that has, the radius is one side of that little blue square in the upper right-hand corner right here. And what it's doing is asking you to compare the area of the circle, what's on the inside, which you have to estimate, to the area of that little perfect square, okay? So if you were counting them out, you'll probably notice, before I show you the answer, here's how I counted them. Sorry, where's my pencil? Under the thing. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whole or nearly whole. And then you do have these little quarter pieces, which there are 4 of them. So we could go ahead and say there's 13 square units here. And compared to a 2 by 2 square, you would end up with 4 square units for the square. Okay, compared to 13 here. I come over and I take a look. Here's what I get. Okay, about 13 square centimeters. If you had said 12, I wouldn't fault you. Okay. And then the area of the little square, sorry, my camera's a little blurry, there it goes. Area equals length times width, area equals 2 times 2, so we get 4 square centimeters. And 13 is roughly 3 times the area of 4, okay? So that circle is roughly 3 times the area of the square. So let me know if you have any questions, and I think that's it.